Wanted to welcome everybody tonight to this month's CSI presentation. My name is Joel Kirshen, president of the chapter here, and welcome everybody to the presentation tonight. We have Mr. Steve Gantner here presenting on tornado shelters. You're joining us both live and then online here tonight. Then with no further ado, I'll turn it over to Steve.
Well, good evening, everyone, and thanks for coming. Appreciate it. So if you'd like to get a hold of CSI, our website is stlouiscsi.org. Please drop us a line, check out what's going on. Thanks to Hank Meinking, who just stepped away from his computer, but he's the one bringing you the audio visual too. Sherwin-Williams is also sponsoring tonight's feast that we're having here, so you guys should really come down in person. I mean, how's that T-bone steak going, guys? Pretty good? And likewise, thanks Hank for and Sherwin-Williams for doing the audio visual for tonight. A little bit about me, just so you guys know who's talking to you. I graduated from the University of Kansas with a degree in architecture. I am registered in the state of Missouri, active in CSI on the local, regional, and national level. I have my certifications in CDT, CCS, and CCCA. Member of SCIP. And I think what's important for this presentation is I'm also active with the Missouri SAVE Coalition, which is the Structural Assessment and Visual Evaluation program through the State Emergency Management Agency. Also a member of the AGC. So as we get going here, I just want to give you a little background. I've always been fascinated by weather. My father was a bricklayer, and I remember from times growing up that as a foreman for the brick company he worked for, he'd have to get up early in the morning and see, is it raining? Is it snowing? Is it too hot? Is it too cold? What was going on? So that interest in weather kind of got passed down to me. And when I was in college, I took a couple classes, and one of my favorite classes was severe and unusual weather. There was a class dedicated to this. We talked about hurricanes, tornadoes, cyclones, haboobs, all kinds of weird things. But of particular interest, since I went to Kansas, was tornadoes. I actually got to watch a tornado form while I was there one year. Freaked my girlfriend out at the time. So learning objectives, we're going to go through the building code tonight with you guys, and it's reference to the ICC 500. And we're going to talk to you a little bit about doors, windows, windborne debris, and some key factors that go into designing a shelter and what the differences are. One of the things I was able to participate in, if you were in November, here in November, you heard me talk a little bit about Joplin, and this is one of the slides from that program. But I was part of the Missouri SAVE Coalition. We went down and evaluated structures, all kinds of structures, from houses to buildings to just sheds. Make sure they were safe to be used. Just a few facts for you. On Sunday, May 22nd, the tornado watch was issued by the National Weather Service at 1:40. The tornado warning went off at 5:17, and the siren sounded at the same time, and at 5:31. The tornado itself touched down, I should say tornadoes, it's plural. There was a double vortex EF5 tornado, and you'll understand a little bit more later on about the EF scale and what the 5 means, but it's the most severe storm you can have. And the time they had to prepare for this storm was 24 minutes from the first time the siren went off to getting in the shelter or getting hunkered down. So this is the damage path from one end of Joplin to the other. Right here's Highway 44 coming down, and this is the heart of Joplin, basically. You can see the damage path several miles long. A little bit before and after photos for you. One street corner. Before you could see the houses, now you see nothing. And on the right-hand side, you see the fields from the what's interesting to this one is the school fields here that you can see, and you can see them damaged here, and the path of damage that went right through there. One thing I can't capture on here is the smell of the town. If you've ever been up in your attic and you have that kind of musty, attic-y smell. I don't know how to describe it. It's not mold. It's insulation. It's all kinds of stuff that you're not used to smelling. That's what the town smelled like. everywhere you went. So damages, there were over 4,300 single-family houses damaged or destroyed, 3,800 damaged. Cell phone towers, there were 50 of them that were not functioning. I'll show you a photo in a minute of one of them. And 10 were destroyed. Most notable damage was to St. John's Regional Hospital. I think that's what everyone saw photos of here in St. Louis. But there's an example on the left-hand side by the truck. There you can see a communication tower laying down on top of an apartment complex. This is one of those power poles that was just kind of bent over and non-functioning. St. John's, they had to move 183 patients out. They moved them out within 90 minutes of the the tornado. Unfortunately, 5 people died, and all those people were connected to the life support systems in the facility, and it was due to power failure. And one visitor was in the hallway. I believe I'm not quite sure how they died. I won't speculate. The building, though, was actually moved physically off of its foundation a few inches. A building that size was moved a few inches. That tells you how strong the winds are. This is one of my favorite photos in a fascinating kind of way, not that somebody lost their home in this, because this is somebody's home. But you can see the front porch right about there. That's where the house is supposed to be, right there. Closer examination, everything looks good. The sill plate's down. You can see the anchor bolts in the sill plate. But if you look a little bit in the other photo, you can see it, but this one you see it better. The top course of the masonry failed. The bond between the CMU and the top course just broke away. Took the plate, took the bolts with it, and it moved the house. This one is an interesting example. Everything to the left of that, you can't see the photo, but everything to the left of that there was nothing. All the houses were gone. The one to the right, the White House on the right, sustained severe damage, was inhabitable. But this one, if you can notice right up here above the garage door, there is a green tag on that building. That green tag means that building was safe to occupy. It was the levels of tagging are: green is safe, yellow is partially safe, you can only go in certain parts of it, and red is don't go in, not safe for habitation. So what we did was, I was walking around with a structural engineer, and we were kind of curious as to why this building was still there when everything else around it was severely damaged. And we noticed that the walls were physically connected to the foundation. So the continuous path of loading went from the foundation up the wall, and we couldn't get into the house, but I suspect they had some sort of strapping or something that went over the joist for the roof. Now moving on to another area I was able to visit after a tornado was Edmond, Oklahoma. I don't know if you remember May of 2013, but during the 3 days there, all these tornadoes were confirmed. May 18th was the easiest day they had. They only had 4 of them. They were in Kansas. May 19th, the one in Edmond, there was 12 in Kansas. You guys can read the slides. A lot of tornadoes. And then the very next day, I believe May 20th was the day the Moore, Oklahoma tornado happened. That damaged a significant chunk of Moore, Oklahoma. What's interesting about this one was I was able to go down and examine a building that was down there. And this is just this is minor exterior damage. This is just debris flying around, hitting windows that were not rated for high winds. What's interesting is, because I actually specified it, I know for a fact that coping up there that you see here is ANSI SPRY ES1 certified coping, but you can see it bent. And I think they bent, speculation only. If you notice the big gap here on the left-hand side where the masonry failed. Not sure if it was a masonry failure or whatnot, but if you look on the other photos, you can see where the course is pulled off here, and that this is one shooting down on top of that. I think that failure might have allowed the wind to come up under that coping and get a hold of the metal that was cleated down, and that caused the rest of the failure. But what's really interesting about this is you think, oh, that should be nothing. That doesn't appear to damage anything except you miss some brick and some, you're missing your coping a little bit. But if you turn around, that's the roof. So if that wind can get up under the coping, and then because the roofing came and flashed over the coping and was tied into the coping, the wind got underneath the roofing, which was mechanically attached first layer, fully adhered second layer, and fully adhered membrane. But you can see the wind got under it and pulled the metal deck up in the one instance over here. And what happened was that metal deck failed. So wind, water, everything got into the building and caused significant damage inside the building. You can also see that this photo over here, the pipe coming up is for a screen for the air handling units. It was severely damaged as well. Inside, a lot of damage from just wind and water that just blew through the building. The wind came in one side. You could track the path by looking in where the wind came in from. Basically that opening right there. It came in this part of the building, came down, came over here, and it blew up that part along with the uplift of the wind, blew that up and allowed the wind to escape from that area as well. So it's fascinating how you can see how that stuff happens. So what we're going to get into a little bit with that behind us is the IBC and where the storm sheltering information comes from. So per section 202, the IBC defines storm shelters. Take notice though, they're not tornado shelters, they're not hurricane shelters, they're just storm shelters at this point. And just for reference, I'll show you where it's defined in the code later. But for planning purposes, you plan to stay in a tornado shelter, storm shelter for 2 hours. A hurricane design time is 24 hours. So you can see there's a little bit of difference as we go through different aspects of the building code. The general component of the IBC applies to construction of storm shelters constructed as separate detached buildings or constructed as rooms or spaces within a building. For the purpose of providing protection from storms that produce high winds, such structures shall be designed to be hurricane shelters, tornado shelters, or combined hurricane tornado shelters. That's language right out of the building code. Design of these facilities for use as emergency shelters after the storm are outside of the scope of ICC 500 and shall comply with table 1604 as risk for structures. So we're going to go outside of ICC right now. We're going to see what the building code says about what types of occupancies need to be need to have storm shelters or emergency shelters, which is two different terms. Emergency shelters have to function, they're essential facilities. They have to function after the event has happened. So they need to be able to occupy them after the tornado or the hurricane has gone through. And you need to build them according to IBC 2018 here, the criteria in this table. Where a building or structure is occupied by 2 or more occupancies not included in the same risk category. Okay, so your risk categories here are, you can see up there, ambulatory care facilities, fire rescue ambulance. But if you have a structure associated with it, okay, that's what we're talking about, shall be assigned the classification of the highest risk category corresponding to the various occupancies. So if it's tied to it, if a fire station is tied to a community center, the community center automatically comes up to that level of design. Critical emergency operations, 911 call centers, emergency operations. The interesting thing is Group E. When the occupancy is 50 or more, it has to be function as a storm shelter constructed in accordance with ICC 500. The only exceptions are Group E, daycare facilities, Group E occupancies as accessories to places of worship. Now, I don't know how that really applies because I know there's some churches that have schools associated with them. I would hope that they would take care to have some storm sheltering somewhere in that facility if it's being built new. Retrofitting is becoming more common, but new ones, I would hope they do the same. And then buildings that meet the requirements of shelter design in ICC 500 don't have to comply. Okay, so we're still in IBC, but we're going to talk about occupant capacity. The required occupant capacity of the storm shelter shall include all of the buildings on the site and shall be the greater of the following. There's two criteria. The total occupant load of the classroom, vocational room, and offices in the Group E occupancy, and the occupant load of any interior assembly space that is associated with the Group E occupancy. So there's where you're getting your churches covered a little bit. There are exceptions, as everything in the building code, right? Where a new building is being added on an existing Group E site, and where the new building is not sufficient size to accommodate the required occupant capacity, the storm shelter shall at a minimum accommodate the required occupancy of the new building. Okay? Hopefully that makes some sense, that building a building, you don't have to accommodate the old building, but the new one has to be. And where code officials can override everything, we remember that. Where approved by the code official, the required occupancy capacity of the shelter shall be permitted to be reduced by the occupant capacity of any existing storm shelters on site. So if you already have a storm shelter, you can take that occupancy off of it and have another one. For instance, the Joplin High School, when they rebuilt it, I saw the plans for, they were gonna have 3 storm shelters in there. One wing was a gymnasium, the center of it was the library, and the other wing, I believe, was the cafeteria. All 3 of those areas were gonna be storm shelters within the building. So where do we put our storm shelters? Storm shelters shall be located within the buildings they serve, or shall be located where the maximum distance of travel from one exterior door of the building to the door of the shelter does not exceed 1,000 feet. So in that example of the high school, that's a reason to have multiple shelters in the facility. Because 21 minutes, that's not a lot of time to get, let's say, 1,000 students into storm shelters. So got to kind of hustle. So what version of the code do we use? Currently, I believe everyone's on 2014 or 18 IBC, or 2018 IBC or 2015. So we're using the 2014 code. Fascinating read if you're interested, about 100 pages, little light reading, keep you up at night. References to FEMA 361. Keep in mind, ICC is the International Code Council. FEMA writes this one. Complying structures in this code are considered safe rooms. ICC is minimum. This one is, you're going to be safe and you can still occupy the facility afterwards. Yes?
I just wanted to ask, what tells you which one you have to follow? Do you have to follow ICC or do you have to go with FEMA?
Great question. At a minimum, you have to follow ICC. That follows the IBC, which references it and brings it into the code. If you're getting money from FEMA, you have to use FEMA too. So you're using the building code and FEMA, which is basically just beefing it up. But there are a lot of grants out there if you want to, back in 2012, 13, after the Joplin tornado, a lot of schools around here were trying to get grants to increase the resistance of their buildings. Quite a few new gymnasiums or retrofitted gymnasiums going on. Good question. Anything else? So there are 9 chapters. I'm going to go through a few of these, not all of them. I just want to give you the layout of the ICC 500. First one we're going to talk about is construction documents. Now, I want to go through some of these points. I'm not going to read them to you per se. I want to tell you what the code says about them so that you're familiar with it. So for the first one, residential or community tornado, hurricane, or a combination of both. So that's the type of shelter. You get 3 choices on that one. The second one is a statement that the wind design conforms to the provisions of the ICC 500 code with the addition year specified. So you need to tell them which version you're using, making sure it's compliant. And then the shelter wind speed in miles per hour. I'll show you the chart in just a minute, but that map of the United States had the wind speeds in it. Just for reference. They don't have to do too much. They just have to design to a 3-second gust of 130 miles an hour. Whereas the dark gray area here in the middle where, the bullseye's right there about St. Louis, our peak wind gust is 250 miles an hour with 3-second wind bursts. So little idea of the wind speeds we're talking about. The wind exposure category, item number 4. That's important because the code defaults to exposure category C, which is basically flat open terrain. And the hurricanes also default to C, but there are provisions to go to B on that one. But it cannot be, for that purpose, it cannot be an urban area. Item number 8, the statement that the shelter has or has not been constructed within an area susceptible to flooding. We don't want to trap all these people inside of a storm shelter and have them drown. That would be horrible. Then we have to get into a few other things: design flood elevation and base flood elevation. Be more about that a little bit later. A floor plan drawing or image, item 11, indicating location of the storm shelter on a site or within a building or facility, including a drawing or image indicating the entire facility. And then you have to provide them some sections and elevations, the heights of the storm shelters related to finished grade. Venting area is also critically important. We need to show them how much venting you're providing within the shelter. That's a requirement that we'll cover in chapter 7. And then, believe it or not, there are sanitation facilities required in storm shelters, community ones, not residential. And then foundation requirements and shelter installation requirements, including anchor location and minimum required capacity. So this isn't something that your typical architect's going to do. They're going to call an engineer to design these anchors to make sure that they can withstand the pullout. If you design your shelter right too, you also have a safe place to go in the event of an earthquake. So that we have the added bonus here in St. Louis of having that. So the next one, we talked a little bit about the map, what you're going to show them. Well, 107.2.2 enclosures. When a storm shelter is to be constructed as a portion of a host, the walls and floors enclosing the shelter shall be clearly indicated on the drawings. This is a drawing from Oklahoma State University, and it is a location where in orange you can see where all of the storm shelters are on their campus. Being in Oklahoma City, it makes a lot of sense. You want to have a lot of storm shelters. The other thing you have to do is note your sign. You note your shelter. Requirements for this are you're going to tell them how much the wind speed was designed for, the missile impact resistance, what it was designed to, and we're going to cover missile impact. And I tried to find some videos to show you guys of that. If you haven't seen it, it's pretty fantastic. Just fun, brain candy. You're going to have inspections of your facility as it's being built. Make sure that everything is being built according to the plans and drawings, specs. Any special details you have to note on your drawings. And then special instructions. So construction documents shall provide or include any special details or special instructions required for the functional operation of the shelter. So we're talking about things like equipment and amenities that are required within the shelter that include water, sanitary, fire extinguishers, batteries, flashlights, emergency lighting, and other equipment required in Chapter 7 to be installed, and the specification for any alarm system to be installed. The third item on that point, though, like this storm window here, this coiling door, protection for the window. Looks like it's in a classroom. That's the easiest way to do it. If you build your outside walls out of masonry, you can achieve a tornado shelter fairly easily from the vertical impact. The horizontal one on the roof is a little more difficult to attain. But if you have a 4-inch concrete slab, you're pretty covered. But the third item, special instructions for the deployment of any special protection equipment, such as shutters, screens, special latching for doors or windows, any equipment or switching, electrical plumbing. You have to have notification within the shelter of how to operate those. Construction documents also have to have a quality assurance plan with detailed requirements. Some of them are showing the roof cladding, soffits and roof framing connections. Remember that house that was connected to the foundation? They want to see how it's connected. They want to see the main wind force resisting system, including your braced frames, wall cladding and the cladding connections, critical support systems and connections, and if it's a prefabricated shelter, what the foundation loads are for those. Quality assurance plan preparation, similar items. They want the main wind force resisting. They want to see your special inspections and testing, what's going to be on there. The structural observations performed in accordance with 106.4, and the required distribution, who gets the test reports, most likely the architect, structural engineer, and the AHJ. So now let's talk about chapter 3, which is the structural design criteria, and we're going to talk about wind loads for a minute. I'm not going to cover design of the facility. This is more engineering heavy, but the important components we'll cover here. Design wind speed for tornado shelters shall be in accordance with figure 304.2.1, which is the United States map with our 250 mile per hour wind. And then hurricane is 304.2. Wind peak gust speeds at 3 miles per hour measured at 33 feet above finished grade. And you can see that the, well, you probably can't see because it's really small. It's over here. I'll read it to you guys. Wind speeds are going to be anywhere from 190 miles an hour to 235 miles an hour gusts. So like tornadoes, I mentioned the EF scale. Hurricanes have their scales. You're familiar with them because you've heard them on the news. Category 1, 2, 3, 4, 5, where 1 is dangerous. Got to respect it. It's still a storm. But 5 being the worst one, get the heck out of Dodge if you can. You don't want to be around it. But if you look, the sustained winds are 157 miles per hour or higher. It's not too bad, is it? We got to do 250. No? So I had a little fun with this. The coastal states say, we have some strong winds in the hurricanes. Like, yeah, right. Hold my beer. So originally, the Fujita scale was 0 to 5, F0 to F5. And you can see the wind speeds are significantly higher here. I'm not quite sure exactly why, but EF numbers got introduced in 2007 and brought the numbers down for how they categorize the damage from the storms. So you can see the double vortex tornado in Joplin was a 5. So they know they had 3-second gusts of over 200 miles an hour. That's just incredible in my mind, those sustained winds. The fun part, debris hazards. And I say that fun as in it's interesting to watch the tests. I'm glad they're doing the tests because I feel safe inside the buildings when they do these tests. But the windborne debris, what you have to design to, we're going to use our area, St. Louis, Missouri, 250 miles per hour wind. So what does that mean? They're going to take this nice little cannon here, take a 15-pound 2x4, and they're going to shoot it at the vertical surface at 100 miles an hour. If it passes all the tests, then it's certified for our area. Likewise, the horizontal surface will get tested in the same way. So they measure, though, horizontal and vertical a little bit differently. They give you some criteria because dirt covering the shelter in 12 inches deep negates the need for the test for 67 miles an hour. And also, you can go from vertical to horizontal at a 30-degree angle. So at 30 degrees, it's considered 30 degrees or less, it's considered a horizontal surface. 30 degrees or more, it's considered a vertical surface. Now, where do we put these things on the site? We already talked about floods. Seems straightforward, right? Not really. Elevation corresponding to the highest recorded flood elevation. That makes sense to me. Maximum flood elevation associated with a model hurricane. That's a hurricane, don't care. Minimum elevation of the lowest floor required by the authority having jurisdiction. Okay, that one, we may pay attention to that one. And then 2 feet above the flood elevation given a 1% annual chance of being equaled or exceeded. Seems like that's happening every year now. Somebody exceeds a floodplain that 500 years ago wasn't supposed to be possible. But so that leaves us with, well, exceptions. Sorry, always exceptions. Items 1 and 3 shall not apply to shelters designed, constructed, designated only as tornado shelters. So let's just take those guys out. So what do? We all like flow charts, and I'm sorry, that's going to be an eye exam. But basically what it says at the very top is, has a flood hazard study been conducted and have flood elevations been published for the area, including the storm shelter site? Yes is on the left, no is on the right. Let's go yes. Is the shelter design constructed, designated, and used only as a tornado shelter? Yes. On the right, left, no on the right. So let's go to the left. So we got to elevate to or above the higher level of the minimum elevation required by the AHJ, or 2 feet above 1% annual chance flood elevation. A little bit easier to calculate if you know about what it is because of the flood hazard study. If you don't have one, then you go to the other side of the table, over here. And we're going to stay on this path here because it's only going to be used as a tornado shelter. So we're going to use item 2, highest recorded flood elevation, or the minimum elevation required by the AHJ. Basically what that says. They also have criteria for hazardous materials. You cannot put a storm shelter in a location that is subject to hazardous materials getting damaged by a wind event. That's a no-no because they do not want you to be subjected to those chemicals, whatever the hazard is that's being stored there. That's all I'm going to cover on chemicals. It's a special case and would get into it if you're in an industrial area. I highly doubt they're going to put a pipeline near a school, but know that it's there in case you need to get into that. So section 403, siting proximity for residential structures. And these are some examples just for your information. This is a prefabricated one. Looks like someone bolted it to their garage floor. 4 inches of concrete with a proper anchorage. That's a great shelter. Grandma and grandpa in their tornado shelter. They're going to be safe. Got some old fashioned ones here going down inside. And then my favorite, the all masonry one. Why not put a bathroom in there in your house? No, put it in the basement. But residential tornado shelters shall be located within the residence that the shelter is intended to serve. So in the building, or located on the site such that the maximum travel distance of at least one path from an access opening to the shelter is not exceed 150 feet. So if you're going to go in the ground out back, make sure that door is within 150 feet of your back door. Community shelters are different. They should be located outside the following high-risk flood hazards, subject to high-velocity wind or wave action. That's a hurricane. We don't need to worry about that. And then floodways. They can be located within flood hazards, though, that are subject to high waves if you get permission. So the AHJ can override everything. A little bit on occupancy. Tornado up here on the very top. Standing or seated, 5 square feet per person. Right below that, wheelchair gets 10 square feet per person. And bedridden is 30 square feet per person. So if you're in a hospital, that's where that one would come into play. You can bring people down from the ICU or from their rooms. Hurricanes are a little different. Remember, two hours versus 24 hours. So you're gonna need a little more space to sit and kind of walk around, wiggle around. That's 20 square feet for standing or seated, 20 for wheelchairs, or 40 for bedridden. Okay, now the fun part. The usable shelter floor area shall be determined by using the following percentages. It's a lot of math. I really didn't want to. There's 3 items you can do it, and I'll read them to you really quick because they're really interesting. I think it'd be hard to do, and there's an option that makes it easier. Reduce the gross floor area of the shelter areas with the areas of concentrated furnishings or fixed seating by a minimum of 50%. Okay. Reduce the gross floor area of the shelter areas with areas of unconcentrated furnishings and without fixed seating by a minimum of 35%. Reduce the gross floor area of shelter areas with areas of open plan furnishings and without fixed seating by a minimum of 15%. Seems like a lot of work to figure it out. They give you this nice alternative. The usable shelter floor area shall be determined by subtracting the gross floor area, the floor area partitions and walls, columns, and fixed or movable objects, furniture, equipment, or other features that under probable conditions cannot be removed. So basically whatever is in the space, take that square footage out of the space, and that is your usable space. So these tables are movable, but in the event of a tornado, we would not take the time to move them. So it's the square foot around the tables that would work. Wheelchair bound. Each storm shelter shall be sized to accommodate a minimum of 1 wheelchair for every 200 shelter occupants. I just had a little fun with this one after that last math slide, which got me thinking. So if 200 is 1 wheelchair, 400 is almost double. That's just 2 wheelchairs. I think you have more people in wheelchairs, but, and then the obscene number of wheelchairs. So number of doors in a community shelter. This is what we would design. This room could be a community shelter if we had beefed up the roof, because that's a 6-inch thick concrete masonry wall out there. All around us is 6-inch CMU. I believe the block has been tested, but I don't know that for a fact. But we could close the doors. We could, you know, there's a number of things that could make this a safe room. But the number of doors, means of egress doors, shall be determined based upon the occupant load for the normal occupancy of the space in accordance with the applicable building code. For facilities used solely for shelters, the number of doors shall be determined in accordance with the applicable building code based upon the occupant load. So go by the building code. That's the number of exits you have to have. All right. Exceptions. Shelters having an occupant load not exceeding 16 are not required to have an emergency escape opening. So we have to have an emergency escape opening for residential. That would be your opening like in a lower level bedroom, below grade, 24 by 30, I believe. I got it in here somewhere. Coming up on it. Direction of swing. The direction of the swing of the doors is required by the applicable code. So if normal code says the door swings in, it swings in. If it swings out, it swings out. The only interesting thing, I'll show you a photo at the end of this show, slideshow. We designed one for a firehouse, and we had a discussion with the fire chief because the door was going to swing out from the space, from the gear room. And we talked to the fire marshal, fire chief about it, and said, you guys are first responders. This was before this code was enacted, but where they wanted a storm shelter. If by chance the building around you collapses, how are you going to get out? Who's going to come rescue you? He goes, good point. Maybe that door ought to swing in. So we reversed the swing on that door. Cost a little bit more to get the door going, but it was worth it because the first responders can get out. But just backtracking a little bit, the code now requires that that entire area of that firehouse would have to remain standing in the event of a storm. So that was before this version of the code. Emergency escape openings shall be an additional door or an opening minimum of 5.7 square feet. That's basically the below grade occupied space requirement. And no more than 44 inches above finished floor level. Means of egress doors shall be operable from the inside without the use of keys or special knowledge or effort. So you can't put in combination locks or anything like that. That's, if your kid can't open it, it can't be there. And they have to be provided with an accessible route in accordance with ICC A117. Residential shelters, like I said, the bolted down type, or this one looks like it's in an area off of a living room or something over here. All residential shelters shall be provided with a method of entry and egress with minimum clear opening of 24 by 30. And then vertical access, like the one on the right, for residential shall be by a stair complying with section 502.3 of the building code. I'm not going to get into the weeds on the means of egress from stairs because that's in the regular building code. So we saw the occupant load for community shelters. For residential, it's a little different. Tornado, 1 and 2 family dwellings is 3 square feet per person, as opposed to a hurricane, which is 7 square feet per person. And then other residential, I'm assuming they're talking apartment complexes or attached residences, 5 square feet. And then for hurricanes, 10 square feet. Usable tornado shelter floor area, basically it's a gross square floor area minus the area of the sanitary facility. If you have a toilet in there or some other fixed seating. This one's a lot easier. I understood that one. Locks and latches, there is an entire section on locks and latches because latching mechanisms shall be permanently mounted on the assembly. Such mechanisms shall require no tools to be engaged in the latched position. Devices such as pins shall be permanently secured to the assembly through the use of chains or wires that must be of corrosion-resistant material. So think of it, if you have a bar or something you're going to put in front of a window or a door, and you put a pin in it, that pin has to be attached to the wall next to it or the jamb, so that you get in the shelter. Hey, what happened to the pin? We're all going to die. Multi-latching systems are not categorized as a means of egress escape and are provided with more than one single action latching mechanism, and they shall be provided with permanently posted instructions. So that one looks like it's a multi-latching, but a single use. So that one doesn't count. But if you had to push a pin up into the ceiling, up into the jamb, down into the floor and into the jamb, that would require permanently labeled instructions saying, make sure you get all those connected. Door latching hardware necessary for the door assembly. Automatically engage when the door is in a closed position and shall not be capable of being disabled or be capable of being engaged by an occupant, and signage shall be provided with instructions for latching the door for the emergency shelter use. Combined safe room, tornado safe room, and hurricane safe rooms all have to be labeled so that people know where to go in the event of an emergency. Fire resistant construction. Fire barriers and horizontal assemblies separating spaces or areas designated as storm shelters shall have a minimum fire resistance rating of 2 hours and shall be constructed in accordance with the applicable part of the building code. The only exception is the fire separation assemblies are not, you don't have to have in a residential shelter. But again, going back to like if you're going to do a masonry wall, your fire resistance rating is already built into it because you're going to grout every cell solid and you've got a nice tornado resistant wall. Fire extinguishers, you have to have them in all community shelters. Wouldn't be a bad idea to have one in your residential one either. Some other things, some other essentials, generators, water fountains, toilets, but you have to protect things like the generator. Critical support systems shall remain functional for the designed storm event and a minimum period of shelter occupancy. 701.1 is where it specifically says 2 hours for residents, 24 hours for a hurricane. I'm sorry, tornado, hurricane. And you have to comply with the flood for your generator and other facilities. You have to comply with the flood requirements, keeping them up out of the floodplain. Ventilation, minimum requirements for ventilation, you have to have it. Natural ventilation shall comply with 702.1.1, basically saying the location of the openings is determined by your calculations. The top part, residential, is 2 square inches per occupant. 50 or less occupants is 5 square inches per occupant, and 50 or more is 6 square inches per occupant. And that can be mechanical or natural. But if it's natural, it has to be clear area. but you have to protect the openings. I'll show you an example of that in a minute. Sanitation facilities, not required for toilet or hand washing in residential. Other residential, you have to have a toilet, but you don't have to have hand washing facility. Community centers, you are required to have 2. I'm just reading it because in case you can't see it. 2 minimum for the first 500 and 1 additional per 500 or portion thereof. Hand washing, 1 per 1,000 occupants. And this is for tornado shelters, not hurricane. Emergency lighting shall be provided in community shelters. A minimum average of 1 foot candle in the occupied shelter. Emergency electrical power shall be designed to provide continuously for a minimum of 2 hours. The exception here is personal use flashlights shall be permitted for the emergency lighting system for tornado shelters with an occupant load of less than or equal to 50 when provided at a quantity of not less than 1 per 10. So on occasion, you can use a flashlight and get away with it, or those brake lights, 1 foot candle. It's what you need. First aid kit. It's a good idea to have one. It's not required for anything unless the shelter is greater than 50. But even in a residential one, I'd put one in there. They're cheap and it's a good preventative thing to have. This next part, I'm just going to tell you that Section 703 exists. It's basically what we just went through with tornadoes, but it's specifically for hurricanes on ventilation, sanitary facilities, other essential features. Okay, it's just greater numbers because the time you're going to spend in it is greater. Now the fun part, missile impact testing. This is where the construction of the facility comes in handy, and knowing the materials that you're going to use and how they can protect the occupants. So on a panel, just think framed wall or roof, typical house or commercial construction. You're going to have a test, and you're going to have to test this panel in 4 locations. But the key component here is no more than 3 impacts shall be made on 1 specimen. Well, we're telling you to do 4. You can't do more than 3, unless you get permission from the owner of the facility and the testing laboratory. So if you have a door and you don't want to pay for the test, you want to take a gamble and shoot it 4 times, go for it. As long as the facility testing will allow you to do it and you own the building. So the impact location, similar situation, within 6 inches from each edge. Imagine how accurate you have to be with a 2x4 cannon to hit that. Within 6 inches. You're going to put one centered in the wall. So between the studs, you're going to hit one of the studs, and then you got to get within 3 inches of a stud on that. Now, when you get to the joint between the roof and the wall, they're adding a couple additional tests or additional panels. You got to hit both panels where they join, right there, or you got to hit the joint between the roof. And then the other tests are still there. Same test. Masonry walls, 2 tests, one in the center of a block and one in the corner. Again, no more than 3, but they only need 2, so that's good. Windows and other glazed openings. If you think about ICUs, the best way to protect an ICU is through a shutter or some sort of other protective opening. I think McKeon makes some. You can also design some that have steel plates. I've seen photographs of elementary schools that have steel shutters that are hinged open, and they have tack board on the one side so that when they're open, they can put drawings and pictures from the students in there. And then if they have to, they slam it closed, put a bar down, and they're protected. Those systems have been tested similar to this. Minimum 2 impacts on this one as well, unless you get permission to do more. The harder component is a door, because the door moves and is open. I know Assa Abloy makes doors that have been tested to this criteria. I believe Allegiant has 2. I'm not 100% certain on that. but the testing on the doors is 3 locations: near the upper latch point, near the a hinge on the one side, and near the handle. Similarly, on a double set of doors, you got to hit it once near the center, just in case. Keep in mind, these are 2x4s, 15 pounds, 100 miles an hour for St. Louis. Protective opening systems, something similar to the shutters. Now, here's an interesting concept because you've probably seen them in public facilities, but number of impacts with alcoves or baffled systems. This is considered a baffled entry system. It's where the debris could come into the opening, hit a wall, and then come back and hit an occupant, or in this instance, another wall. Went too fast. So this scenario, you're protected, the occupant's protected by 2 impacts. You're not required to, this is considered 2 impacts. The first one will hit this wall, the second one will hit that wall before it gets to the protected area. So a normal door would work in that scenario. The next one, though, is a little different because an occupant could be hit by debris, not hitting a second wall. The theory is that it hits the one wall, it slows down, it hits the other wall, it becomes non-harmful. I don't know how they figured that, but I trust them. The missile on this one, though, the door still has to meet the requirements of a tornado. However, the testing criteria dropped significantly. Instead of a 15-pound 2x4 at 100 miles an hour, it's a 9-pound 2x4 at 50 feet per second. So it's slightly less weight and speed. Door subject to first impact. If a first strike angle missile impact on the door is possible, then the door is deemed suitable if the door assembly meets the wind requirements that we've had before. But if the door withstands the impact, has to be tested. It can be reduced. The test on this one can be reduced to 9 pounds at 50 feet per second because it's semi-protected. It's not going to take a direct hit. It's at an angle. So you're protecting the occupants from a direct strike. This is the detail I was telling you about for that storm shelter for the fire department. This is the actual structural plan that we used. And you can see detail 12 is the interior partition here. And detail 12 is right here. So what you can't read is that's an 8-inch CMU with number 6 vertical at 8 inches on center. And we have seismic joint reinforcing at 16 inches on center, grouted solid. Okay. The other wall is the exterior wall of the facility. That's a 12-inch load-bearing CMU wall with 2 number 6 vertical at 8 inches on center with seismic at 16 inches on center, grouted solid. So that's a pretty beefy wall. And what I didn't get a shot of is the roof assembly on that. You have to have a minimum of 4-inch concrete cover on top of that roof. And this is what it looks like. This is the door that used to swing out, but now it swings in. And those doors are heavy. I don't know if you've ever had the opportunity to see one, but they swing heavy, they feel heavy, and it, tell you what, you want to get a bunch of carpenters mad at you, tell them to put one of those doors in. It takes like 3 of them to move it. And the protective, opening protective. This is the back wall in that 12-inch CMU wall. It's open to the outside. Keep in mind, this is the previous version of the code. But what we had them do was basically put a grid of bars in there that were prescribed by the old code that would shatter anything that was possibly coming into the room. It was over the heads of everybody, but it was, let me see here. Number 5 rebar at 8 inches on center at the opening. Minimum embed of 8 inches into the block that's fully grouted all the way around it. So anything hitting that would get stuck in it or get shattered. But that's the ventilation for that room. Here's an example of a residential storm shelter. You can see the venting they've got here. Got their CMU walls. They put their forms up, and then didn't know what they did when they poured the concrete, but I'm assuming it was a grout that they used to put in here, and then they just filled the rest of it up with concrete to form the lid of that shelter. Community shelter with the baffled alcove. This one would take a direct hit, so the door would, you can see the door barely on that one right there. That door would need to be tested per the 9-pound impact. That is my presentation. I hope I didn't bore you to all to death. Codes are a really interesting thing, I know. Any questions? Anything online? Yes.
For the concrete roofing that you're talking about, is there reinforcement requirements also called out in the code for the decking?
There are concrete reinforcement requirements. I don't know what they are. I didn't get into that. That's part in chapter 3,
Right,
where they prescribe the layout of the reinforcing steel and everything. But yeah, there is.
Have you heard anything about expected changes that might come from the Amazon warehouse and those tilt-up panels that came down and all of that?
Good question. Heard about? No. Will there be? Almost definitely. After any disaster, this code wasn't, this is 2014's version. This is the direct result of what happened in Joplin and the Oklahoma tornado spree in Moore, Oklahoma. So I'm sure there will be changes as they've built these facilities on this code. They're going to go back and check these buildings that were built as this code and see where they succeeded and failed, and make modifications as required. That's how the codes get updated. I think that's the reason we don't have non-fire rated metal composite panels now, because of the Grenfell thing. So, any other questions?
So just had this happen recently where a facility that we're working on is located and it's been there for quite a while. It's kind of in a low point, but it's not considered a flooding area from records. But there's been so much development and everybody's been getting by with accommodations for stormwater management that being at the bottom of the hill, the sewers can no longer handle massive rains. So they're flooding. So I guess my point being is you might want to check and see what local events, sometimes it's not mapped is I guess what I'm saying. You have to almost check with the local communities to see if you're in a low area, you might be prone to something. And then I was actually going to comment on that in out, does the door swing in or out? We were in Oklahoma. It was right after we were doing a tornado shelter for a credit union, right after the more Edmond tornadoes that came through. And I believe the FEMA requirement is that the door swings in. The code requirement is the door swings out. And we literally had a building code official and the fire marshal arguing about which direction the door was supposed to go. I think it came down to they insisted on it swinging outward. So the fire marshal actually lost, which was a surprise.
And it was a FEMA, was it a FEMA granted building?
It was not.
Okay.
They argued about it. We were trying to build to a pretty high standard when we could, but it gets really expensive really, really fast when you're going for FEMA.
Yeah. Yeah. FEMA's a fun animal trying to get a grant, because that would have been a no-brainer. FEMA wins if it was a grant. Otherwise, you don't get your money. So. FEMA also, just for your information, FEMA has a guide for residential structures as well. That one was for community, but they also have a guide for residential.
Are there any provisions within this code for automatic shutoffs in residential related to natural gas?
There are none.
Blows away, you're in your safe room, but it starts on fire, would the gas shut off, or are they requiring anything like that in the mechanical portions?
And not that I saw.
Thank you.
Would make sense. Unless you get down in your shelter for a tornado warning and then you got to call the fleet or Spire to come turn your gas back on.
Okay, yeah, so the first question is, do hand washing in shelters need hot water, like hand washing stations?
That's a good question. I did not get that far into the weeds on that.
Okay,
I would assume the normal building code requires something of the sort. I have the code here, so take a quick peek while you read the next question.
okay. Next question, it just says accessibility for tornado shelters, any different?
No, you have to comply with A117
Okay,
and the building code. So accessibility still stays the same. You have to have the width requirements to get wheelchairs in there and or beds.
okay.
So you have to comply with those items. I'm getting there. Hold on. Chapter 7. I need to get to chapter 7. Sanitation facilities, required toilets and hand washing. Water supply. It does not say anything in there about hot or cold water. Just temporary sanitary fixtures. Chemical toilets also work. So I would assume just running water. But don't take my word for it. Pick up a copy of the code. And seriously, that is a cursory view of the code from my perspective too. So definitely, if you're going to design a tornado shelter, pick up the ICC 500. If you have any questions, I think my name's on there below all that stuff. Yeah, feel free to shoot me an email or give me a call. Be happy to chat about it. Like I said, weather and tornadoes are a fascination of mine. I'm always willing to go the extra mile to make sure that we keep people safe in a storm. Except for myself, I'm the idiot that'll be standing on my front porch when a tornado comes. So if you see me on the news in a tree somewhere, I was just being stupid. Anything else? All right. Well, really appreciate it, guys. Thank you very much. This was fun.